Hello there, wind energy students. Dr. John Schrage here, and I just wanted to have a little bit of a lecture that's associated with the first page or two of this chapter, just to kind of sort out why do we need a chapter about this anyway? Why do we need a chapter about the local winds? I mean, we've been learning about winds for several chapters now. We learned about all these forces and all these processes and so on that were controlling the wind. Why do we need a specific chapter that's about the local wind? What do we mean by the local wind? Well, everything that we've learned so far in this course has kind of implicitly assumed that the air was flowing over a surface that was flat and uniform. Whatever that surface was, you know, whatever its properties were, they weren't like we're talking about terrain all that much, and we weren't talking about like obstacles, and we weren't talking about changes in roughness and so on, with a little bit of an exception back in Module 4. But these were pretty gross simplifications. The real flow in an individual at any given location is also dependent on local effects, small scale things that can be changing the flow. So based on that, we could make different kinds of models based on different scales of flow. You might remember this term, we had this back in Chapter 2, I believe, where we were learning about things like global scale versus synoptic scale versus mesoscale versus microscale. Make sure you review those ideas if you don't already know them. But remember, there were just different sizes of weather phenomena that we were interested in. And the truth is, at any given location, the real flow is actually a composite of all of those features of the atmosphere. There are aspects of the flow that are being controlled by like the large-scale disposition of cyclones and anticyclones and fronts and all that kind of good stuff. But there's also maybe mesoscale weather features going on, like maybe squall lines of thunderstorms or something like that. And there could be microscale effects right in your immediate area associated with maybe obstacles to the flow and maybe thermal circulations associated with presence of water versus land and things like that. All of which combine to make the actual flow that you observe in an area. Now, it might seem like the right strategy then here is just to forget about all the scales except for the smallest scale, the microscale, and just simulate the weather at every location using a microscale analysis of what's going on. Really understand the flow at literally the scale of like meters. Okay, that seems like a good plan, but in practice we don't have the computer power to do such a thing. We generally need to understand large-scale meteorology, the cyclones, the anticyclones, what the jet stream is doing, monsoons, hurricanes, all the kind of good stuff we learned earlier in the course, and then we sort of embed little local microscale effects within there, where we start understanding, okay, this is what the large-scale weather pattern is doing, but this is how the wind is flowing as it goes over this mountain, or as it goes around this obstacle, or as we experience this change in the roughness, and so on. This is interesting. This kind of has given a hint to the fact that in this module of the course, we're actually addressing four main kinds of local effects on the wind. And your author sorts them out as orography, that's going to be things like terrain features, roughness, the actual like texture of the surface itself, in terms of like, you know, the uniform texture of the plants or the urban environment or whatever, obstacles to the flow, isolated individual objects that the flow has to adapt to, and thermally driven flows, which are based on differences in temperature and density of the air at the surface based on things that are happening at the surface. All of this is going to be helping us have a more realistic impression of what the flow is going to look like at an individual location. So we really need to start attacking some of these much more local phenomena if we're going to understand what the total composite flow at a location looks like. All right. I don't see any reason to have any questions or anything like that associated with this little introduction to the lecture. It's just that it might not have been entirely clear where we were going with this if we just dived right into the lecture about orography. Alright, please let me know if you have any questions about this, and navigate back to Blue Line to move on to your first lecture in this module, which I believe is orography.